Hello everyone, welcome to this CATIA training session. In this exercise, we will model a complex sheet metal part together. We will use part design step by step to build the full geometry. Let's start and learn it in a professional way.
I was dreaming in my sleep, now wide awake. With Kathy up by my side, there's no mistake. Always had a wish to create and design. Now I'm building futures one line at a time. Could sketch a ship or design a plane. With Kathia, every dream I can sustain. Stay with me, I'll show you how it's done. Our journey to the stars has just begun. Dreams with Kathia come alive, stay tuned. In a world of possibilities, our talents bloomed. From the sketch pad to reality, watch us soar. With every click and curve, we crave for more. From the smallest bolt to towering steel, with Kathia, our thoughts become real. Together we'll create wonders to see. In this world of design, just you and me. Step aside now, let's make way.
Hello everyone. Today we are going to draw this shape together. As you can see, the shape is given as a sheet metal part. Pay attention to its thickness. It is 3 millimeters. The best way to create such shapes is to use the Generative Shape Design workbench. But we want to create it in the part design environment. As usual, we first analyze the shape. The center part of the shape is a rectangular shape with rounded edges. From both the length and width sides, two inclined surfaces are connected to it. The challenge of this shape is creating fillets and grooves on the inclined surfaces. I set the coordinate system at the center of the oval rectangle. I also define the coordinate axis. I go to a sketcher using the XY plane. First, I draw an elongated hole horizontally. I define its size and then set its position. The horizontal axis of this element is aligned with the main coordinate horizontal axis. I return to part design. I give the pad command to the created shape. The height is 50 millimeters. Now I go to sketcher again on the top surface. I draw two circles with 30 millimeters diameter. I position the circles. I return to part design. I remove the two circles from the main body using the pocket command. Again, I go to a sketcher on the top face of the first shape. I draw a circle with 55 mm diameter at the origin. I return to part design. I give it a 20 mm pad. Now I create fillets between the oval rectangle and the 55 mm circle. I click on the Edge Fillet tool to open its settings. The fillet value is 15 mm. I set the propagation mode to minimal. I select the edges of the oval rectangle and the cylinder one by one. I do not want the fillet to affect the edges of the 30 mm holes, so I define these edges in the edge to keep section. After setting everything, I click OK. I view the shape from the top and compare it with the drawing. I show you the weak point of the shape with the mouse. Now I want to create the inclined side surfaces. First, I start with the small parts connected to the rounded surface. I go to Sketcher using the ZX plane. I obtain the intersection view of the round surface with the ZX plane. I create an arc using the 3-point method. I make the lower point of the arc coincident with the horizontal axis. I set the distance of the lower point from the vertical axis to 125 mm. I set the arc radius to 250 mm. I create a line parallel to the yellow line. I give it an approximate distance so it becomes constrained. This distance must be enough so that the padded edges stay inside the round surface. On the other hand, it must not enter the 30 mm hole. The lower point is aligned with the horizontal axis. I changed the color of this line to red. Now I draw a horizontal line. The distance of this horizontal line from the horizontal axis is 20 mm. I trim its edge at the yellow line to get a point. Now notice the top point of the arc must connect to the red line. Also, the intersection of the arc and yellow line must be 20 mm from the horizontal axis. I must adjust the top point so both conditions are satisfied. I move the end point of the arc onto the red vertical line. I align the arc at the intersection of the horizontal line and yellow line. I trim the extra parts of the lines. Now I draw a horizontal line to close the sketch. I return to Part Design. I apply a two-sided pad of 25 mm. The shape is created. I mirror the shape. Now I apply a 10 mm fillet to the edges. Remember, you cannot mirror a fillet directly. Now I go to a sketcher using the YZ plane. First, I use the intersect tool to get a projection of the side surface and filleted area. I draw a horizontal line that crosses the projected line. The distance of this line from the horizontal axis is 40 millimeters. Now you can see the line is in the fillet area. So I create a vertical line at the distance from the projected line. You must define this distance from the projected line. This distance is approximate. Using quick trim, I cut the outer part of the horizontal line relative to the arc. I create an arc. I align the lower point of the arc with the horizontal axis. I set its distance from the vertical axis to 125 millimeters. I set the arc radius to 250 millimeters. Note that if the arc center is constrained, remove it. I move the arc end into the shape. I also align the arc end with the vertical line. I align the arc body with the horizontal line. I delete extra parts of the vertical line. I also fully constrain the rest of the sketch. I draw a horizontal line from the start of the arc to the start of the vertical line to close the sketch. I return to part design. I give the sketch a two-sided pad of 25 millimeters. The shape is created. I mirror it relative to the ZX plane. I apply a 10 mm fillet to the edges. I set the view from the top. You can see the shape. Now I activate the shell tool. I set inside thickness to 1 mm and outside thickness to 1 mm. I select the bottom face as the removing face. I click OK. The shape becomes a shell. Now I set a total thickness of 2 mm. I double-click the shell tool in the tree to edit it. I set one thickness to 1.5 mm. I click Preview. I get an error message. I try to smooth the surface automatically and manually. The error is not solved. I changed the thickness back to 1 mm. Now I apply fillets to the edges of the 30 mm hole. I click the fillet tool to open settings. The fillet value is 2 mm. I select the edges and click OK. The fillet is created. Now look at the shape. On the inclined surfaces, grooves are visible. A section of the groove is shown. You can see the edges are rounded with a 4 mm radius. Now I face two problems. First, the inclined surfaces are not straight. Second, the groove edges are rounded. I measure the distance between fillet edges. The value 30 mm matches the drawing. First, I create a body. I create a point on the inclined surface using point on surface. The distance of the point from the two edges of the fillet is approximate. I change the color and shape of the point to make it visible. According to the drawing, three grooves exist on the larger inclined surfaces. The distance of the top and bottom grooves is not equal to the adjacent edges. The spacing between grooves is symmetric. I activate the line tool. I select normal to surface. I select the surface. I select the point. Now I have a point and a line. With them I can define an axis system. I click Access System in Tools toolbar. The Settings window opens. I keep the standard option. I select the origin point. A coordinate system appears. If you look closely, it is similar to the main coordinate system. Now I click the Z-axis field. I select the created line. The axis system rotates. The Z-axis aligns with the selected line. I click OK. I enter a sketcher using the XZ plane. I draw an elongated hole. I set its radius to 4 mm. I draw a vertical line. I align this line with the center line of the elongated hole. I trim extra parts. I will give the necessary dimensions and make constraints. The vertical line should coincide with the x-axis. The length of the pinhole is 30 mm. Its edge matches the edge of the fillet. The sketch is fully constrained. I draw another vertical center line. I return to part environment. I use shaft tool with free and 160 degrees. Now we have a cylinder with a rounded head shape. I activate Remove from Boolean tools. I select Body in Remove. Part Body is selected in From. I click OK. I show the cut section. For the second groove, I create another axis system. I create a body. I create a point and a line. I define a coordinate system using them. I repeat the same process and create the shape. I subtract the created volume from part body using Boolean. I return to main access system. I create the remaining holes and fillets. I view the shape from below. The lower edges are still not filleted. I apply fillets there as well. I use dynamic sectioning to inspect the shape from both sides. Before using this tool, make sure the main access system is active. Otherwise, quick view tools will not show correct direction. I will explain coordinate systems in another lesson. Remember, every time you create a new access system, you can see it in the tree. The active system is highlighted by CATIA. In version 32, you must right-click the active system. At the bottom of the menu, its name is shown. However, over it, another menu opens. Click Set as Not Current. Now the main coordinate system becomes active. The exercise is finished. In this exercise, we saw that due to unsuitable surfaces, we could not apply 3 mm thickness. Anyway, this shape is better created in more advanced environments. I hope you enjoyed this exercise. Goodbye until the next lesson.